Due to the size of marine engines, it's not possible to have a two-stroke engine in an academic lab environment. NTUA marine-related research is mostly conducted on the field, which means onboard vessels, shipyards, engine-making facilities, etc., and also in the lab using special one-cylinder research engines. NTUA Internal Combustion Engine Laboratory has single and multi-cylinder four-stroke test engines, which are used for the following activities which are related to the marine sector. For much more detailed investigations, a single-cylinder Ricardo Hydra test engine is mounted on a test bed which is used. The engine can be equipped with two types of cylinder heads, which means compression ignition, spark ignited operation. Engine can be operated under both motored and fired conditions, and this specific installation is suitable for combustion analysis, emission formation analysis, combustion rate analysis, effect of engine tuning on performance and emissions, testing of alternative fuels and their blends, which means biofuels, methane, diesel combustion, etc. This has already been done in our laboratory. Dual fuel studies, natural gas and diesel, simulation of faults and their analysis, estimation of friction losses from engine, additive testing, and evaluation of energy-saving devices. In order to do this, NTUA is equipped with a full set of analyzers for the following emissions: NOx, NO, NO2, hydrocarbons, CO, CO2, exhaust smoke number, filter smoke number, and oxygen. The analyzers operating using prototype methods as required by MARPOL Annex 6. NTUA Internal Combustion Engine Laboratory has two portable MARPOL type approved analyzers which are suitable for onboard emission measurement. Now, NTUA is also equipped with a small single-cylinder test engine which has been modified from our technical staff for dual fuel operation. Tests can be conducted using various diesel and natural gas ratios. A natural gas fuel supply line exists in the laboratory. The multi-cylinder testing facility equipped with a heavy-duty multi-cylinder industrial test engine. The engine is loaded using a hydraulic brake, and it is equipped with both cylinder pressure sensors and fuel injection system pressure sensors. This installation is suitable for emission studies. We have conducted in the past both steady and transient state measurement and testing, alternative fuel testing and performance measurements. We also have a single-cylinder test engine which has been modified for cylinder pressure sensor testing under actual conditions. The installation is very important for testing of sensors which are used for onboard measurement equipment and also for the testing of sensors which are used for state-of-the-art electronic engines.
My name is Sotiros Karellas and I am the director of the Laboratory of Thermal Processes. In this video, I will guide you to the marine activities in which both labs are jointly working towards the increase of energy efficiency and energy savings in the ships. Our laboratories have been working within the last years in the development of waste heat recovery technologies such as the organic cracking cycle and sorption cooling towards the realization of zero waste heat in industrial processes, but also in marine applications. The ambitious targets set by the IMO for reducing the greenhouse gas emissions for shipping are very challenging and require radical actions to be taken by all relevant stakeholders, as well as a holistic approach to energy-efficient vessel retrofitting and design. Within this framework, the laboratories have developed an innovative marine ORC plant for the utilization of low-temperature heat from ship engines. This plant is able to utilize heat of around 90 degrees Celsius and produce electricity and heating for the needs of the ship. The organic Rankine cycle prototype exhibits impressive features such as human-machine interface, autonomous operation, ramp-up, ramp-down behavior. In Greece, it is one of the first ever designed and constructed systems for low-temperature marine applications and one of the first worldwide. At the very promising Horizon 2020 European project Engymonia, in which our laboratories are responsible for the scientific coordination of the project, the focus is the development of energy efficiency solutions and operational practices providing assistance in the design and development of the organic Rankine cycle system. In the renovated steam boiler facility of the Laboratory of Steam Boilers and Thermal Plants, it is possible to produce up to 11 bars of saturated steam with a total power of 2 MW thermal. In the current state, the facility can provide thermal conversion systems either directly with steam or with water glycol mixture streams with the help of two large heat exchangers of 700 kW thermal each. The testing facility enables full control over the stream's temperature and flow rates, enabling a wide range of testing of any novel waste heat utilization unit, such as the 100 kW electric ORC that will be provided by the company Orkan in the scope of the Engymonia project. In addition to the ORC, two other technologies will be investigated in the project: an adsorption chiller and a series of photovoltaics. My team will be responsible for the technology's evaluation, the ship's energy management design and operation, environmental and economic or techno-economic aspects, including the visualization of the integrated system performance to compare the different solutions for various ship types. Within 2022, our laboratories are going to participate in a new Horizon Europe project aiming at zero waste heat in the ships. In this project, the labs will work on the design and production of an organic Rankine cycle system using waste heat towards the production of electricity, heating and cooling. Both laboratories are very active in research towards waste heat in ships. With their developed know-how, their prototypes and demonstrators, the laboratories are showing the path towards efficient waste heat recovery with low environmental impact.
I'm Irene Koronaki and I'm an associate professor in the School of Mechanical Engineering. Also, I'm the director of Laboratory of Applied Thermodynamics, which is one of the oldest laboratories in the National Technical University of Athens. Our field of interest is the design, analysis, simulation and optimization of a wide range of topics in the field of thermodynamics and energy sector of engineering, like thermodynamic systems and cycles, open-air evaporative air conditioning systems using liquid and solid absorbents, heat exchanger performance for shore and marine applications, solar thermal hybrid energy systems, thermal cryocooler Stirling engines, injector cooling units and combined absorption units. Several experimental setups have been constructed and installed in the lab in order to validate the developed codes and to promote the research in up-to-date energy fields. The NTUA Laboratory of Applied Thermodynamics is a pioneering risk in the study of thermal and cryocooler Stirling engines. Many codes have been developed for the thermodynamic analysis, and a solo 161 Stirling CHP unit is installed in the lab here for the thermodynamic analysis and optimization of Stirling engines. They are used for shore applications, especially for electrical power production, for marine applications in submarines and in the space industry. A solar cooling system is installed in order to examine the potential of thermal storage and solar cooling under Athens climatic conditions. The cooling effect is produced using a single-stage 2-bed zeolite water adsorption chiller. The system is evaluated in terms of solar collectors, useful energy production, heat stored in the intermediate buffer and cooling system's performance. It consists of 9 main components: vacuum tube solar collectors, photovoltaic thermal collectors, buffer storage tank, an adsorption chiller, a latent thermal storage tank with phase change materials for high enthalpy water, latent thermal storage tank with PCM for low enthalpy water used in the circulation of adsorption chiller, a dry cooler, and electrical resistance and pumps. Another unit is a liquid desiccant cooling unit. It is a solar thermal-driven cooling system which provides air conditioning and dehumidification only with water and lithium chloride salt. The system uses water as a cooling medium and lithium chloride aqueous solution as the desiccant. It is an environmental friendly unit as well as with the previous one, with zero ozone depletion and global warming potential. Another unit is a rotary adsorption dehumidification system. This type of system allows drying the air very efficiently down to almost 0% of relative humidity. Systems like this have a wide and varied scope in food industry, libraries, museums, production of semiconductors and production of pharmaceutical products.
My name is Dimitrios Kouloheris and I am Associate Professor at the School of Mechanical Engineering and Director of Vehicles Laboratory. Vehicles Laboratory was founded before 20 years and its main objective is to provide research and teaching in the areas of ground vehicle dynamics, design of superstructures and components of systems, and intelligent transportation systems. Lab has a fully equipped machine workshop which serves teaching and research activities. The Vehicles Laboratory supports core and master courses, providing laboratory exercises to more than 200 students annually. Furthermore, it gives students the ability to conduct diploma, master, doctorate and postdoctoral theses in the areas of ground vehicles design. We offer lessons such as theory of ground vehicles, vehicle dynamics and design, hybrid electric vehicles, mechanical design, and also optimum product design engineering and transportation systems. Main research activities are structural analysis, CAD/CAE of vehicles and components, dynamic behavior modeling of vehicles and their systems, dynamic measurements of heavy vehicles and subsystems such as suspension, steering, and electric and hybrid vehicles, design of lightweight structures and innovative suspension systems. For the simulations, we use commercial software and we develop also our codes. We participate in all these years in more than 80 competitive programs funded from EC, General Secretary of Research in Greece, and many companies. Total budget of the programs is more than 10 million euros. We have cooperation with research centers and universities, and we collaborate with public services and communities in the above areas. Also, we serve the industry with special engineering services such as dynamic measurements of heavy vehicles, design of optimum heavy vehicle superstructures, optimal design of school bus floor, special seats and anchor wrenches, estimation of driving behavior using vehicle dynamic measurements, and last, accident reconstruction analysis. More information about our facilities and services you can find on the web page of the lab.